Template convert an existing open data resource into linked data and connect it to something else. I mainly choose the concept data as my data source. So I use New York Philharmonic concept data, Carnegie Hall data, music brains, etc. And my goal of this project is to transform these concept datasets into a linked data format and connect them with each other. This will allow us to explore more complex questions about music history and trends. I think this is a very interesting topic, so I chose it. And my implementation can be divided into these steps. First is schema analysis. So in this first step, I need to get a deep understanding of the data source. Here, this is the sample data I downloaded from New York Philharmonic concept data. And after downloaded, I do some data cleaning and I manually organize it, and I use this website to generate an ontology map based on this data source. So in this map you can see it shows program, concept, soloist, work, conductor, composer, their relationship very clearly. This map helps me to get better understanding of the data source and help me do the future work. And then is write some code. I use Python to do the data convert process. I need to convert the source data in JSON format into RDF format. I think this is the most important step. I will explain it later. And then output RDF result, and next load the result to graph database. This is the tool I use. So I set it locally, and you can use this tool to do some query based on the RDF data. Okay, and next let me show you the data pipeline I write use Python. I mainly use RDF library in Python. So first I define these four namespaces, and then I write these three functions. These three functions is mainly link RDF graph with external data source by identifying known entities such as program ID, orchestra name, composer name. So here I just hard code it. In the future I will improve the logic here. Yeah, I write some to-do task, and then I initialize RDF graph and the byte namespace. And this add literal is a tool function to add a literal value to the RDF graph. Then it's process program function. This is the main logic here. This function is mainly process a single program entry and convert it into RDF data. You can see inside this function, I try to get the orchestra name, and I try to link the orchestra to external data source such as Wikidata, music brains, and I also try to link program, concepts, and works. Next, similar function. This process concepts is process concepts associated with a program, and then we have process works and process soloist, and then load data function, clean data, export data. Okay, in our main function, first we initialize graph, and then we load and clean data, and after we confirm, press Y, and we call this function process program. This function will process each program in our data set and convert it into RDF graph, and that's the export data. Okay, let me run this program. I press Y to continue. You can see it runs successfully, and it outputs the file output.ttl, this file. Let me explain this file. Take this code for example. It means this one is a subject, and it representing the unique identifier for a program. You can see this means the subject type is program, and this subject has some properties, such as this program has concept, and this concept links to a specific concept event, and it has work. Here we link to 3 different works performed in this program, and it has orchestra. It links to an orchestra, and it has program ID. It has season. Yeah, so you see, actually it's very easy to understanding. Last, we can output this result into graph database. I set it locally, and because I already imported the data before, and you can see I already implement some query based on the data. Yeah, this is what I want to get in the end. Okay, thanks for watching.